Here I have a question that says the points A 1, 1 and B 5, 9 lie on a curve that has the equation 6y is equal to 5x square minus 18x plus 19. And in the first part of this question, I need to show that the equation of the perpendicular bisector of AB is 2y is equal to 13 minus x. So let's suppose that this curve of 6y is equal to 5x square minus 18x plus 19 looks something like this. Let's just imagine that it looks like this. And points A and B lie on this curve. So let's suppose that point A is somewhere over here on this curve and point B is over here on this curve. This is point A that has the coordinates 1, 1 and this is point B that has the coordinates of 5, 9. And the line joining A and B would look like this. Now this is the line AB and the perpendicular bisector of AB would pass through the midpoint of this line. This is the midpoint and the perpendicular bisector would look like this. And these two lines intersect at a 90-degree angle. Now I need to find the equation of the perpendicular bisector. I am going to find the equation using the formula y minus y1 is equal to m times x minus x1. In order to use this formula, I need to know two things. The first is the gradient of the line and the second is any one point whose x coordinates and y coordinates are known, that is present on the line. Let's first find the gradient of this perpendicular bisector. I don't have any point on this perpendicular bisector, so I can't use the formula of the gradient, that is y2 minus y1 divided by x2 minus x1. I can't use this formula right now because I don't know points on this line. What I can use is the relationship between these two perpendicular lines. You know that when two lines are perpendicular, the product of their gradients is equal to minus 1. I can find the gradient of this white line by using the formula. So let's say that this is line 1. So the gradient of line 1 I am going to denote as m1. It's going to be equal to y2 minus y1 divided by x2 minus x1. If this point is x1 y1 and this is x2 y2, the gradient would be equal to 9 minus 1 divided by 5 minus 1. This would be equal to 8 upon 4, which is equal to 2. So the gradient of this white line is 2. Now for the gradient of the perpendicular bisector, I can put this value in this equation and I'll get 2 times m2 is equal to negative 1, and that would give me m2 as negative 1 upon 2. So this is the gradient of the perpendicular bisector. Now after finding the gradient, I need any one point on this line whose x coordinate and y coordinate are known. I do know that this perpendicular bisector passes through the midpoint of this white line, and I can find the midpoint of this white line using the formula x1 plus x2 divided by 2, y1 plus y2 divided by 2. This would be 1 plus 5 upon 2, 1 plus 9 upon 2. And this can be simplified into 3, 5. So the coordinates of midpoint are 3, 5. Now since I have both the gradient and the point on the line, I can move on to find the equation of this perpendicular bisector. So the equation would be y minus the y coordinate is 5 is equal to the gradient is minus 1 upon 2 times x minus x1. The x coordinate is 3, so x minus 3. Now if I multiply this by minus 1 upon 2, I'll get y minus 5 is equal to minus 1 upon 2x plus 3 upon 2, because minus 1 upon 2 times minus 3 is positive 3 upon 2. Adding 5 on both sides would give me y is equal to minus 1 upon 2x, and 3 upon 2 plus 5 is 13 upon 2. So plus 13 upon 2. This is the equation of this perpendicular bisector. This is my answer for the first part of the question. Now in the next part of the question, it is told that the perpendicular bisector of AB meets the curve at C and D. So this is the perpendicular bisector and this red line is the curve. And these two are intersecting at 2 points C and D. And since I drew this sketch completely by imagination, you can't see over here that this bisector can cross the curve at 2 points. But if I redraw this, it would look something like this. This is the curve. This is the line AB. And this is the perpendicular bisector of AB. And the perpendicular bisector and the curve are intersecting each other at 2 points, and the name of those 2 points are C and D. So I'll erase this previous sketch. Now I need to find the distance CD in the form of square root P upon Q. Before finding the distance CD, I need to find the coordinates of C and the coordinates of D. And to find these coordinates, we are going to solve the equation of this perpendicular bisector and the equation of this curve simultaneously. The equation of the perpendicular bisector is y is equal to minus 1 upon 2x plus 13 upon 2. And the equation of the curve is 6y is equal to 5x square minus 18x plus 19. This is the first equation and this is the second equation. I am going to solve these two equations by the method of substitution, and since in equation 1 y is already a subject, so I am going to substitute the value of y from equation 1 into equation 2, and I'll get 6 times minus 1 upon 2x plus 13 upon 2 is equal to 5x square minus 18x plus 19. 6 times minus 1 upon 2x is going to give me minus 3x, and 6 times 13 upon 2 is going to give me 39. This is equal to 5x square minus 18x plus 19. Sending these two terms on the other side would give me 5x square minus 18x plus 19 plus 3x minus 39 is equal to 0. Minus 18x plus 3x is going to give me minus 15x. So 5x square minus 15x, and 19 minus 39 is going to give me minus 20. This is equal to 0. In this equation, if I take 5 common, I'll get x square minus 3x minus 4 is equal to 0. Now if I divide both sides of the equation by 5, I'll get x square minus 3x minus 4 is equal to 0. Now I'm going to solve this quadratic equation by breaking the middle term, and that would give me x square minus 4x plus x minus 4 is equal to 0. In the first two terms, if I take x common, I'll get x times x minus 4. And in the last two terms, nothing is common, so I'll take 1 common, so x minus 4 is equal to 0. This gives me x plus 1 times x minus 4 is equal to 0. And that gives me x as minus 1 and x as 4. So one of these 2 points of intersection has the x coordinate of minus 1 and the other has the x coordinate of 4. Now to find the corresponding values of y, I am going to first put this minus 1 in either one of these two equations. Since the first equation is more simpler, I'll put this minus 1 in the first equation to get the corresponding value of y at point C, and similarly then I'll put 4 in the first equation to get the corresponding value of y at point D. So first at point C, the y coordinate is going to be equal to minus 1 upon 2x, and the value of the x coordinate is minus 1, so minus 1 upon 2 times minus 1 plus 13 upon 2. Minus 1 upon 2 times minus 1 is positive 1 upon 2, and 1 upon 2 plus 13 upon 2 is equal to 7. So the coordinates of point C are minus 1, 7, and for point D, at point D, the y coordinate is going to be equal to minus 1 upon 2x. The value of x over here is 4, so minus 1 upon 2 times 4 plus 13 upon 2. 4 divided by 2 is 2, so y is equal to minus 2 plus 13 upon 2, which is equal to 9 upon 2. So the coordinates of point D are 4, 9 upon 2. Now since we have found the coordinates of both of these points, let's find the distance CD. We have learned that the formula of the distance is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Let's name this coordinate as x1, y1 and this as x2, y2. So this would be equal to square root of x2 is 4 and x1 is minus 1. So 4 minus and minus 1 would give me 4 plus 1 whole square plus y2 minus y1. So 9 upon 2 minus 7 whole square. 4 plus 1 is 5. So the distance would be equal to square root of 5 square plus, and 9 upon 2 minus 7 is minus 5 upon 2 whole square. 5 square we know is 25. So the distance would be equal to square root of 25 plus, and minus 5 upon 2 whole square is 25 upon 4. 25 plus 25 upon 4 is equal to 125 upon 4. So this would be equal to square root of 125 upon 4. We have learned from indices that whenever we have a square root over a fraction, we can write it as square root of numerator divided by square root of denominator. So this I can write as square root of 125 divided by square root of 4. Square root of 125 is 5 square root 5 and square root of 4 is 2. So this is the distance between points C and D. But since in the question it was asked to find the answer in the form of square root p upon q, so I can leave my answer in this form, where the value of p is 125 and the value of q is 4. This is my answer.